All right, in chapter 8 here, quadratics, the last chapter, by the way, of Algebra 1, we're going to be studying these quadratics. Now, here's what makes a quadratic function. It must be in the form of y is equal to ax squared plus bx plus c, where a, b, and c are real numbers, and a cannot be equal to 0. So if we have numbers here, here, and here, where a is not equal to 0, we have what's called a quadratic function. Now, so far, we have talked about linear functions. What do you get when you graph a linear function? Well, how about a line? And then we're going to be talking about these quadratic functions as we go through this chapter. So let's just determine this first set of problems. Decide yes or no. Is this quadratic? As long as you have an x squared, it's quadratic. So this one would be yes. Number 2, is this quadratic? Well, no, because when we use the distributive property here, we get 7x plus 21, and that's a linear equation, not quadratic. Remember, quadratic has to have the x squared. In number 3, is this quadratic? Well, do we have the x squared? Yes, we do. So this is yes, this is quadratic. Now, I want to know what a, b, and c are. Well, let's go back to number 1. What's a equal to? What's the number in front of the x squared, the coefficient? Well, a is equal to 3. B is the coefficient of the x term, that's -4, and c is the number that's all by itself. It's called the constant term, and that's 1. Well, what's in front of the x squared here? -10, right? But a is not equal to -10 in this case. Why not? Because we have to get it in this form. This is called standard form, by the way. We've talked about that before. We know what standard form is. That's where you start with the highest exponent first and then rewrite it so that you have descending powers of the variable. You remember that? Well, we have to have the y by itself. How are we going to get that y by itself? Is we're going to add 10x squared to both sides of the equal sign. Get y is equal to 10x squared minus 4x and then plus 9. We don't have any like terms over here, so we can't combine any of those. So it's just y is equal to 10x squared minus 4x plus 9. And in this case, a is equal to 10, b is equal to -4, and c is equal to 9. Well, how about number 4? Is this quadratic? Do we have an x squared? No. Number 5. Something squared, isn't it? And when you square the quantity x plus 1, doesn't that mean we're going to be taking x plus 1 times x plus 1? How are we going to be solving this one? Aren't we going to be using FOIL to simplify that? So, if I take this x plus 1 and square it, I don't know what happened there that I got that line in there. Anyway, I'm taking x plus 1 and squaring it. That means I'm going to take x plus 1 times x plus 1. And foiling this, remember, the x times x is going to get you the x squared. And yes, the 1 times 1 is going to give you the positive 1. But don't forget the bottom part of FOIL. 1x here, 1x here, and I get plus 2x in the middle. So I get x squared plus 2x plus 1. And now I'm going to bring down this y is equal to 5 plus all that. And if I were to write this in descending powers, I'm going to have to combine the 5 and the 1. And descending powers, I get x squared plus 2x plus 6. So all of that is equal to x squared plus 2x plus 6. So y is equal to x squared plus 2x plus 6. That would make it, yes, this is quadratic. We get a is equal to 1, b is equal to 2, and c is equal to 6. And number 6, I need to get this y by itself. What do I need to do? Get rid of the 12x squared from the left side of the equal sign to the right side. But before I do that, look what I have here. 10 minus 6, that's equal to 4. So I'm going to subtract 12x squared from both sides. I'll get 2y is equal to negative 12x squared plus 4 because it's a positive 4. Dividing everything by 2, I get y is equal to negative 6x squared plus 2. Now remember, the a is the number that's in front of the x squared, the coefficient of the x squared term. What's that? Negative 6. And c is the is the constant term, the number that's out here by itself. It's 2. But what's b? What's the coefficient of the x term? Well, there isn't an x term, and that would make b equal to 0. Well, we talked earlier about what we get when we graph a linear function. What did we say? We get a line, right? Well, here the graph of a quadratic function is called a parabola. And parabolas are very important in our everyday lives, in science, and everything that we do is based on parabolas. And the reason why, I won't go into all the explanation right now about parabolas, but let's say you're out playing ball. You throw a ball up in the air and it has to come back down, right? That is called a parabola. And if you were to take, say, let's say we have telephone lines. And you know how the wire droops from one pole to the next? That droop, that sag there, is in the form of a parabola. And there's all kinds of different applications for parabolas that we're not going to get into now, but just suffice it to say that when we draw these, because we are going to be graphing them, when you draw a parabola, I want you to picture a ball being thrown up in the air, or a cable or a string or a rope or something like that being sagging between 2 points, like if you were holding up a rope between 2 points. Okay, so that's what we're going to be looking at. Now, what I'm going to do here is I'm going to graph these quadratic functions, and that means I'm going to be drawing parabolas. So I'm going to have x be equal to negative 3, negative 2, negative 1, 0, and 1. And I'm going to plug those things in for x squared and for the x into x squared plus 2x minus 1. Please use parentheses when you are using your calculators, meaning this. The x is going to go in parentheses. That's the negative 3. And I'm going to square it, plus 2 times negative 3 minus 1. Plug that into your calculator and see what you get. Do the same thing with negative 2, negative 1, 0, and 1. Go ahead and plug those into your calculator and pause the video for just a second while you figure those out. If done correctly, you would have gotten negative 3, 2, negative 2, negative 1, negative 1, negative 2, 0, negative 1, and 1, negative 2, and come up with this parabola right here. Notice how it's drooping between, this is a drooping string between 2 points. If you're holding up a string and letting it sag like that, that's what it's going to look like. In number 8, let's try this one. You're going to have x be equal to negative 1, 0, 1, 2, and 3. We're going to plug this in for into the equation negative x squared plus 2x minus 1. When you do that, make sure that this negative here is on the outside of the parentheses, and what goes inside the parentheses? negative 1, and it'll be squared plus 2 times negative 1 minus 1. Here's the negative that's outside the parentheses. Then you're going to go 0 squared plus 2 times 0 minus 1. Then you're going to have negative outside the parentheses, and then 1 squared plus 2 times 1 minus 1. The negative outside, the 2 goes inside. It'll be squared plus 2 times 2 minus 1. And then negative, and then 3 squared plus 2 times 3 minus 1. Go ahead and do those computations and pause the video while you do that and come back when you're done. All right, you should have gotten negative 1, negative 4, 0, negative 1, 1, 0, 2, negative 1, and 3, negative 4. And when you draw your parabola, this one's going to be like the ball being thrown up in the air. So we'd start here, we would come up, it's curving at the top, and then coming back down. Okay? It doesn't go up to a V and straight back down, or you can't get a rope to come down to a V and go back up. This is a nice, smooth curve, just like if you had thrown a ball up into the air, and you'll get that as your parabola. You go ahead and do number 9. Having done that correctly, you would have gotten negative 2, negative 3, negative 1, 0, 0, 1, 1, 0, and 2, negative 3. And again, this is going to be the ball thrown up in the air, so make it a nice smooth curve, and you'll have your parabola there. Let's move on to the second page. Now, how can you determine the direction the parabola is going to end up opening up? Well, let's go back and look at the first 2 examples that we graphed. In number 7, noticing how this one's opening upward. This is considered opening up. The opening is going up like this. And in number 8, it's opening down. This was said to be opening downward. Okay? Well, look at the difference between the 2 different problems. We have x squared plus 2x minus 1 and negative x squared plus 2x minus 1. What's the only differences here? The coefficient of x squared. The a is equal to 1 here, and a is equal to negative 1 here. This one's opening up, this one's opening down. So what's the rule? All right, the rule is that the sign of a will determine which direction it opens. The parabola opens up if a is greater than 0. Meaning if a is positive. And the parabola opens down if a is less than 0, meaning a is negative. Now here's a thought for you. What happens when a is equal to 0? We'll talk about that in class, but give it some thought. See what you can come up with. Anyway, we need to state the direction the parabola will open, name a, b, and c first. And number 10, what's a equal to? It's not negative 5. We have to add 5x squared to both sides, and we get 5x squared plus 2x minus 6. So a is equal to 5, b is equal to 2, and c is equal to negative 6. So this one opens up. In number 11, this is in standard form. Remember, we want these in standard form, descending powers of the variable. And a is equal to negative 3. B is equal to 1. C is equal to negative 1. And this one opens down. How about 12? What's a equal to? Well, it's not 1/2 because we have to subtract the 1/2 x squared from both sides. So y is equal to negative 1/2 x squared plus 2x plus 1. That means a is equal to negative 1/2, b is equal to 2, c is equal to 1, and this one opens down. In number 13, oh, this one's different. What do we have here? Well, we have 1x squared. Is this quadratic? Yeah, as long as you have an x squared, you have a quadratic. So just remember that all you need is the x squared. Well, what's a equal to? 1. There's a 1 in front of that x squared. Now remember that x, how many of these x's do you see in this problem? I didn't mean to write that like that. How many x terms are there? There are 0, so b is equal to 0. What's the number that's out here by itself? Well, there isn't one, so that means c is equal to 0. So we have a is equal to 1, b is equal to 0, c is equal to 0, and because a is positive, it opens up. All right, a couple definitions that we need to talk about. The vertex. The vertex is the point, and I stress point, because the vertex, when we name it, you're going to need the x and the y. So it's the point where the parabola changes direction. Now think about this. Here's your parabola. It goes up, 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 right? And then at some point, it reaches its very top and then starts coming down. Well, that top of the very top of the end, the vertex is, excuse me, the very top of the parabola is the vertex, and that's the point we'll be finding eventually. That's where the parabola actually changes direction, stops going up and starts coming down, and vice versa. If you're hanging a rope, you know, letting it droop between your hands, it's coming down, 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 and then there is a specific point when it stops going on the downside and starts coming up on the upside. And again, that point is called the vertex. Well, the minimum is the vertex on a parabola that opens upward. Think about what we just drew right here. The minimum, it won't ever get lower than that point. The graph will never be lower than that. So that's called the minimum. That's the vertex of a parabola that opens up. And think about our other one over here. It's a maximum. Think about it. If it can't get any higher than that and it starts to come down on the other side, that's the maximum. So the vertex of a parabola that opens down. The domain is the set of x's, right? These are the numbers I get to use for x. And the range is the y's. Those are the numbers that I get for y. And we'll talk more exactly what we mean by domain and range a little bit later on. But let's do this. Let's go back to number 7, 8, and 9. And let's figure out what the vertex is. I'll show you how to do that. So let's go back to the first page. And let's do some erasing here. I'm going to need a little bit of room here. Here's how you find the vertex. We have a formula that says x is equal to negative b over 2a. There's a negative sign there. Now we're going to use this formula to find the vertex. That's not the formula for the vertex, but it's the formula that we're going to use to find the vertex. And what did we say A, B, and C were here in number 7? We said A is equal to 1, B is equal to 2, and C is equal to -1. So let's plug these in. Here's the negative sign in front of the fraction bar. What's B equal to? 2. Then we're going to plug in 2 times A, which is 1, and x equals -1. We're going to use this -1 to figure out what the vertex is. What we'll do is we'll take this -1 and plug it in for these x's here. And if we'll notice, we already did that when we made our table. So -1, -2. Look at this, -1, -2. That's our vertex. That's at the very bottom of this parabola. That's our minimum. Look at number 8. Do the same thing. X equals -b over 2a. Now, in this case, and we're going to come up with the same number here, it looks like, right? Or not the same number, but we're going to do the same thing, and we're going to get b is equal to 2 over 2 times, and then what's a equal to here? -1. So x is equal to, now if you'll notice, we have a double negative here, which is going to make this number what? Positive. A double negative will make this positive. 2 over 2 is 1. So x equals 1 is what we're going to use to find the vertex. Well, we have that right here. And we came up with 1, 0 being the vertex. So, and look at this, 1, 0. It's the very top of this parabola that is opening downward. Well, we'll talk more about graphing parabolas in the next section. Go ahead and do your assignment. Good luck, and we'll talk to you next time.